Hello and welcome to Zero to Abel, where I use my product management skills to show you how to build from scratch. However, today we're not jumping straight into building. Instead, I want to talk about something I think a lot of people, not just product managers, are getting overwhelmed by: AI. Let's be honest, it's everywhere right now. Every week it feels like there's a new tool, some new jargon to learn, all this new hype going around. It's like everyone else is using it and everyone seems to be building cool stuff and they all talk like experts while you're standing there wondering, did I just get left behind? Well, honestly, not yet. There's still time. Most people, even the ones who seem to know it all, they're still figuring it out too. The only difference is that they started to do something about it. So instead of feeling left behind, the best thing that you can do is to also start learning. And that's why I want to share a method to give you some structure to help you better think how to approach and understand the process of building with GenAI. Think of it like a map. I've broken down into 4 main parts and about 7 to 8 stages. Now, it's important to call out, I am not trying to tell you that building with GenAI is a straightforward linear process, but instead I want to help you cut through the noise and see where you are in the bigger picture. It's simple. By the end, my goal is that you will feel more grounded, you'll have better questions to ask, and most importantly, how to keep moving forward with confidence. But before we even talk about data, models, tools, let's zoom out, all right? Here's the best part. The premise of building with GenAI does not change how we approach an opportunity. We still have to solve problems that impact real people. The use case I'll walk you through today centers on a real challenge facing everyday people. That's helping breast cancer patients get matched to potentially life-saving clinical studies. Here's the truth. There's thousands of clinical studies recruiting right now, but connecting the right patient to the right trial is cumbersome. Some of the people on the front lines of this work are called care navigators, professionals who guide patients through the maze of options, and that's where GenAI has the potential to make a real change. So, with that in mind, let's dive in. Begin with part 1. All right, let's get started. The GenAI development process. Now, I told you I broke this down into 4 main parts, 7 to 8 stages. Start off with part 1, which is identifying the opportunity. Then we're going to talk about part 2, which is make the data work for you. Eventually to part 3, which is make the models work for you, and the last part, ship and learn. All right, so let's get going here. We are going to talk about stage 1, frame the problem and the opportunity. So I want you to picture this. The care navigators that I spoke about earlier that help breast cancer patients find clinical trials, they are overwhelmed just by the dense amount of data that is related to finding clinical trials. Patients who should qualify for a trial often slip through the cracks. Our goal isn't to replace care navigators, it's to support them. So the real question becomes, how might we make the breast cancer pre-screening process more effective and in turn streamlined so that patients are matched to the right clinical trials with confidence? Something about clinical trial eligibility, the criteria and the detail are very specific. It's all about who can be included and who must be excluded. And working through them can get significantly overwhelming. That's why we approach this the same way that we would have any real world problem. We try to understand who's struggling the most, what are the pain points, and what does good look like for the care teams and their patients. And also, how could GenAI help without creating false certainty or even worse, risking patient safety? These are things to keep in mind. All right, but to help with all of that, we first need the right information. So let's move on to part 2, make data work for you. Now, there are 2 stages involved in the make data work for you. Before we can build anything, we need data. And that's not unique to GenAI. That is foundational for any application. For our use case, Bowhead Navigator, we needed data from 2 places. First, the patient side, such things like response from medical surveys, clinical notes, and anything from oncology reports, usually in PDF format that describe the tumor's genetic profile and other biomarkers. And second, we also need data from the breast cancer trial side, such as eligibility criteria and exclusion criteria that came from a website called clinicaltrials.gov. Plus, we also need guidance from oncology and cancer authoritative sources. All right. Now, the next step is you got to prepare this data. That's stage 3. So, collecting the right data is only half of the work. The AI model that you'll end up using, it's just not gonna be able to take in like a massive PDF or a massive spreadsheet and know exactly what to do with that, right? We need to prepare this data into usable inputs, meaning smaller, well-labeled chunks that the AI can actually search and reference, In GenAI terms, these are what are referred to as chunks with metadata. So first, we clean up the data, making sure the information was consistent, easy to read, and structured in the same way across sources. Then, we break the large documents into smaller, meaningful pieces the model can search through, what GenAI calls chunks. And by the way, there's so many things about chunks and chunking. We'll talk about that some other time. All right, back to chunks. Then, with the help of very talented engineers, labels are added to each chunk. Things like whether it came from a patient survey, a medical report, a clinical trial description, and also what cancer type or biomarker is referring to. These labels is basically the metadata, extra context about the data itself, and this is how we make it much easier for the model to retrieve the right information later on. This process is essential to give the model a way to represent chunks by meaning, not just keywords. Engineers did all this by converting each chunk into a mathematical representation of its meaning. This is what GenAI calls embedding. Think of embeddings as basically long list of numbers, and chunks with similar meaning end up closer together in that space. Those embeddings get stored in a special type of database built for this purpose, and those are what we call the vector databases. In our case, I remember that we use Chroma for that. Now, back to our Care Navigator. When they go ahead and ask a question, the pipeline first retrieves the most relevant chunks with their metadata, and then only then generates an answer grounded in that evidence. That process, retrieval first, then generating, is what is called or referred to as RAG, R-A-G, retrieval augmented generation. So with a solid input in place, the next step becomes which model fits and why. Let's go on to part 3, make the models work for you. In part 3, we got stage 4, select the model. So once the data is in place, the next big question usually is, which model should we use, right? The different models have different strengths. Some are very good at general conversation, while others are trained for more specific domains. In our case, with the Care Navigators and the breast cancer clinical trials, we compared 2 models. The first one, GPT-4, as you all know, very powerful general purpose model. The second one was Metatron, which is an open biomedical model fine-tuned specifically for healthcare. We ended up testing them side by side to see which one was better at answering cancer-related questions and also matching the patients to the relevant clinical trials. There's multiple ways to compare 2 models. Often people use observability and evaluation platforms. Basically, think of it like a type of tool that lets you track how the model is performing. It measures things such as accuracy, clarity, and the reliability. In our case, we used LangFuse. This is what is referred to as model evaluation and selection. Sometimes the right answer isn't in one model or the other, but maybe a combination of both, a hybrid approach per se. That's exactly what we did. Basically, GPT-4 for natural, patient-friendly conversations, and Metatron when deeper clinical trial details were needed. Now on to stage 5, adapting the model. Of course, even the best model doesn't work perfectly out of the box. For a specialized domain like oncology, we need to shape how models understand and use context. A RAG pipeline could pull the right trial documents, but the model sometimes will miss some of the reasoning behind it. An example was it would overlook some of the exclusion criteria such as age limits, related health conditions, or certain biomarker combinations. To bridge that gap, we layer additional structure on top of retrieval in the form of a knowledge graph. We represented clinical criteria as connected concepts like age threshold, cancer type, gene mutation, with relationships such as inclusion and exclusion criteria. It's like drawing a map of conditions our system can follow. By combining that structured logic with our RAG pipeline, the system didn't just find content, it could also reason through the eligibility, something that it was having trouble doing earlier. At the same time, we refine how we ask the model questions using prompt engineering or structured patterns that guide clarity. Together, these changes made the system feel intelligent, not just reactive. All right, on to stage 6. Evaluate and improve. Finally, we need to find out, is the system actually working the way we want it to? We tested this in multiple ways. We score outputs using a framework called RAGAS, R-A-G-A-S. Think of it like a report card that checks if an answer was relevant, faithful to the source, and well-grounded in the context. But numbers aren't enough. Clinical experts also review responses to ensure they align with cancer care guidelines and that they didn't miss any subtle eligibility rules that we are not privy to. Or most importantly, we gather feedback from the actual users, the care navigators, the people in the front lines who are going to be using this tool to help support their patients. They provided some great feedback, such as, hey, this response is way too technical, or even when a trial match skipped over a key detail. This process is called evaluation, and in GenAI, it's not a one-time test. It's a continuous loop, measuring, spotting weak points, and making all the improvements like adjusting prompts, updating the data, or refining some of the system logic. Over time, these iterations make the system more accurate, trustworthy, and most importantly, user-friendly. So now, with the model selected, adapted, and continuously improved, we were ready to put the system into the hands of care navigators so that they could support those breast cancer patients seeking to find clinical trials. All right, part 4, ship and learn. Stage 7, deploy to production. Once we were confident in the system, it's time to put it in the hands of the actual care navigators. On the surface, deployment looks pretty familiar, right? APIs, backend services, infrastructure, yada yada. But with GenAI, there are a few unique moves that we need to pay attention to. Now, if you recall, we used two models, GPT-4 and Metatron. We served them through a lightweight backend so that this way our user-facing application could handle user queries very smoothly. But more importantly, we didn't just deploy the AI, we deployed the evaluation pipeline alongside with it. That means that as soon as someone asked a question, we could see how the model responded in real time. What made this so effective is that our metrics weren't just generic. We tracked things that actually matter for our use case for clinical trial matching. Was the answer relevant to the patient's case? Did it include the right trial information? And because scoring logic was modular, we could adjust criteria as we learn more without rebuilding the whole system. This is called deployment with observability, getting the model live, but also making sure that you can see, trace, and adapt its behavior as users interact. All right. With that, let's go on to stage 8, the final one, monitor and improve. Getting the system live in the hands of users was only the start. The real work was in watching it perform, learning from it, and making it better. We track model accuracy in real time with built-in scoring, grading answers on relevance and grounding. We also monitor trends over time. Did performance improve week by week, or did it slip as new data was coming in? Engineers watch system health to make sure queries stay fast and reliable. But automated metrics weren't enough. Clinical experts flagged answers that were technically correct, but missed the right tone or skipped a nuance in the criteria. And care navigators gave us feedback on usability also. What sounded too complex, what felt unclear, what felt clear, and where the matches didn't fully quite land with the patient's profile. This is continuous evaluation and iteration. Even in GenAI, when you launch something, you just don't walk away. You keep monitoring, tuning prompts, refining logic, and adjusting safeguards. That's how the system stays accurate, trustworthy, and aligned with real-world use cases. So that's it. That's the full journey. We broke GenAI product development into 4 parts. So let's go over them one last time. Part 1, remember, identify the opportunity. Make sure that you're solving problems for real people. Part 2, make data usable. Collect, clean, chunk, add context so the model can actually work with the information. Part 3, make models work for you. Choose and adapt models, add retrieval and logic, and shape the prompt so that the system reasons correctly. And part 4, ship and learn. Deploy with observability, gather real user feedback, and iterate continuously. And that's about 7 to 8 stages according to my map, right? This is all it is. It's really just a map that you can come back to and reference. The point isn't to memorize every model or every tool or every framework at that. It's just to have a way to really find yourself when the GenAI landscape feels overwhelming. So next time that you're trying to solve a challenge and you're wondering if you should leverage AI, you can always ask, which part am I actually in right now? Am I trying to identify an opportunity? Am I preparing the data, or are we trying to adopt the model here, right? And then you'll know what step to follow and what sort of like area you might be in. If you leave with just one thing, let it be this. GenAI development isn't magic. It's a process. You can learn it, repeat it, and get better at, step by step. Let's go.